Section 13.9 is called slip and slip speed. And what we're going to do is we're going to develop an equation, will be equation 13.2, that will allow us to quantify motor slip. Again, remember, motor slip is the difference between the rotating magnetic field speed and the rotor speed. All right, so just keep that in mind. Now, let's look at this equation and work a little problem with it. So I decided to go back to this figure 13.2 to just sort of make this point about slip and slip speed. Okay, so what we're talking about is internal here in the stator of the motor, we bring in 3 phases of electricity into here, which we'll call the junction box, phase A, B, and C. And then what happens is, you know, of course, we looked at how the interior of the stator is constructed and, you know, all that sort of thing with phase groups and so forth and so on. And so we learned that there is this equation for the synchronous speed, and it is equal to this, okay? Frequency divided by poles times 120, all right? And so what we want to see is we want to quantify the difference, and it'll be a percentage of the speed of this synchronous field and the actual speed of the rotor, okay? So they won't be the same. And as we learned, we have to have that difference between the rotor speed and the synchronous speed to be able to develop a voltage. And without a voltage, we don't get any current, and without any current, none of this works, right? Okay, so there is an equation to quantify slip, and it is given to us as slip is equal to the synchronous speed minus the rotor speed, and that is all divided by the synchronous speed. Okay, now, unfortunately, and I'm going to send you all a video here later about you know, us being in the lab to do that and not being able to pull this off this semester. But, you know, we have a great lab that allows us to make these measurements, and we could measure both of them and we could see how this would work. But this is the slip, this is the synchronous speed, this is the rotor speed, and the slip, you know, some things to remember. For instance, at startup, the slip is approximately 1, okay? It is approximately 1 because this rotor speed at startup is 0. So synchronous speed minus 0 is synchronous speed divided by synchronous speed, which would give us 1, okay? So he says, let's go out here, got a little room, and he says, I have a half horsepower, 6-pole induction motor, 3-phase, 60 hertz. Okay, this is the output power. This is the number of poles in the motor. And whenever you're given this, you know, this kind of stuff, we call that nameplate information. And that half horsepower is the power available to the shaft to do useful work. He says if the full load speed is 1140 RPM, calculate the slip. Okay? Well, this takes a little bit of creativity to get there, but if we go back to 13.1, which gives us synchronous speed as this, we can determine what the synchronous speed is because we know this is 60. Now, I want to give you one little thing here. In all these calculations, most of the time in the United States, when we're talking about AC induction motors, this numerator is going to be 7,200 because we're going to be at 60 hertz, okay? Now, he also tells us that the number of poles is 6. So I end up with 7,200 on the top, divided by 6, and 6 will go into 7,200, and the answer to that is 1,200 RPMs. Well, we feel like we've done something, but we haven't answered the question because What we want to know is what the slip is. And that's where we need to plug into this equation to be able to determine what that is. So N sub S is 1200. And the speed of the rotor at the full load is 1140. I divide that by 1200. This is going to be 60 over 1200. And that comes out to be a number that I don't know. What is that? Let's see. I can't do that in my head. I can't do anything in my head anymore. But anyway, what it comes out to be is 0.05 or 5%. And when we were reading about motor slip, we know that that's a reasonable answer. That's a reasonable answer for a smaller motor, which it is. It's a 1/2 horsepower motor. Okay, that's our example 13.2. And I think we're done with 13.9. We'll get ready for the next one.